Hello, welcome to my channel. So in the last two videos we discussed regarding the basic terminologies of tree and also the binary tree and its types. So in this tree we will write some code regarding the binary tree and how to insert nodes in that binary tree. So before that I forgot to tell you one thing, that in the binary tree, that in this tree there is one property, that is all the nodes. Okay, so I'm tell you regarding this referring to this node. Okay, so all the node values which are smaller than this node will be at its left, and all the node values which are greater than the value of this node will be at its right. For example, if I have 3 as the root node, then 4 will be at its right, 2 will be at its left. Now if I insert 1, it will check this root node. 1 is less than 3, yes, it will go here. Now it will check here that 1, if is it greater or less than 2, it says it is less, so it come here, and here it is no node, so it will get connected over here. So that is one of the property and one of the most important property of binary tree, that the value which are less than a particular node comes at its left, and the node value which are greater than this any particular node comes at its right. Okay, so with this we will start writing the a basic tree code, a custom tree code, and try to implement a node into that. Okay, so since we know tree is not an inbuilt data structure like array list, array list and other, so we have to write it by ourselves. It is an abstract data type, so we'll make a class of node. Okay, class node, it is the inner class of this tree. Okay, class node. Then the data members, as I told, it has 3 part. That is, first the value, we will take value as integer. Okay, so that's why I wrote int, let it be val. Then two data members which are of node type, that is pointers, which is left pointer and right pointer, indicating the left and right child. Then we'll make a constructor, we'll make this as public node, then pass the data members. Okay, so in this constructor we'll take only the value, and later on we'll assign. So this dot val equals to val, this dot left equals to null. Initially we'll make the left and right child as null, treating it as a isolated node or the leaf node. Now we'll close this as well. So we now wrote the node class having 3 data members. First is the data type in which you are trying to accept the value I have taken as int, and 2 are the pointers, that is the left and right pointer of which type, node type, that is a inner class type, node type. Now I'll write the insert method, that how we'll insert. Okay, so before starting that I need to tell that actually tree is one of the best data structure to revise or to strong your recursion, because recursion is very much important in tree data structure. So if your recursion is not that much strong, no problem. By the end of this playlist, you'll be very much confident in recursion, and slowly and gradually you'll be able to solve all the questions. Okay, so now look carefully. In the insert, the return type that I'll take, that is a node type. I'm making a function node insert. Okay, and take value, and I will take a value here as the root. I'll take two parameters. First is the root of that tree, and other that I'll take is the value that I want to insert. Now I'll look again at this property which I told that the if I look at this node, all the values which are less than this will come here to its left, and all the values which are greater than this node will come here at its right. So similarly, I'll simply write a story in the form of a code. Okay. Now I'll leave some space over here like this much, and now what I'll do, I'll simply write root dot left. Okay, what I'll do, I'll for this I'll check later on. Okay, now I'll check over here. Okay, so like before starting with the code, let me take one example. Okay, so let us imagine I have this tree and I want to insert a node at here. So it will check for each and every node. First it will check this node. Okay, now this particular value has to be greater than this, that's why it is in its right. It should be greater than this. Then for this it should also be greater than this, but for this it should be less than this. So I can see that we are using if conditions again and again, and initially this was empty. So whenever I'll hit a null condition, I will insert a node. Like if I want to insert this node, right, but before inserting this position was null. So whenever I will hit the null condition, I will insert that node. And overall I'll use if conditions, checking the conditions whether it is less or greater. Okay, so and one more thing, that in the tree there is no duplicates, so there is no condition of equal to. Will simply check less than or greater than. So here I will write that if root dot val, if the value of the root, if it is greater than this val, that means if value is greater than this, if the value at this node is greater than the required value, then it should come at the left. Then I will write root dot left equals to, I'll call the insert. Okay, and I'll pass on the root dot left and the same value. Okay, now the another condition, if root dot val, if it is less than the val, then I will go at the right, root dot right. I will again call this insert function, and what I will pass here, I will pass root dot left. Now you might have a doubt that why I am assigning this. I'll tell you later on when I'll that's why I skipped this much of space over here. Root dot right, sorry, comma val. With this I end these two conditions, and at last I will return root. Okay, now about this, I told that before inserting this particular node, this position would have been null. Okay, this value will compare, it is greater than this, it is greater than this, it is less than this. But now it will call root dot left, and this left and the left of it is null. So now there is no condition for null, I have to write this condition for now. Now I will write if root equals to null, then what I will do, I will create one node. I will create one object of node, return new node and pass on this value. Okay, now as I will return this will be assigned to this root.left. Before there was null. Now if I will create a node and return this node, it will be assigned to this root.left, that is root.left equal to new node. That's why I assigned root.left equals to call this insert function, root.right equals to call this insert function, and at last I return the root of the tree, so that I can again further I can call this function with the root. So this is how the insert function is. It is simply just like a story which I told, that we will check the two conditions. I'll assign root.left, root.right, at last I will return root, and here if there is null condition, that means we have come at this position, and now we will create one node and return that node, and rest all of it the recursion will handle. So this is what a simple tree insert function looks like. So thank you for watching.